in this example, what do we know? We know, because that's the important thing, the real axis, the image under T of the real axis in the z-plane is going to a circle in the w-plane. Find the equation of the circle. So what do we know? Well, we don't know the, in the z-plane, we know that we're on the real axis, that's this one, and that is going over to the w-plane, and the w-plane is going to be a circle, but we don't know where it is or how big or anything. So we know about the z-plane. So the first thing we do is write down what we know. Now, it's no good writing down the real axis in words, so I've got two options. The real axis can be described like this, y equals 0, that's the real axis, or I could do it in a loci form. I'll do both for fun, which I could maybe do the perpendicular bisector of I and minus I. So z minus I equals z plus I. So loci form or Cartesian form. Now, what we're going to do with the, I'll do the loci form first, is we're going to now sub in z equals. I haven't got z equals, it's going to be a little bit of work, won't take too long. W equals 1 over z plus I, w lots of z plus I is 1, z plus I is 1 over w, z is 1 over w minus I. Okay, so now that I've done that, I can sub in, it's a little bit of extra work, I can sub that in to what I know. So 1 over w minus I equals 1 over w minus I plus I. Simplifying, 1 over w minus 2i w over w, you'll see why I did that in a minute, is 1 over w. Right, so on the top I've got 1 minus 2iw all over w. This is just the fiddling round now. I'm going to use the fact that the modulus of the top, of the fraction is the modulus of the top over the modulus of the bottom. And what else can I do? I can cancel these mod w's off the bottom, giving me 1 minus 2iw equals 1, because the modulus of 1 is 1. Okay, it's a good start. I'm not recognising it just yet. Let's give myself a bit more room. I think I need to pull this 2i out, because I want w minus something inside here. So I'll write it as minus 2i lots of w minus 1, minus 1 over 2i. I think that's right. Expand that out, then you get minus 2iw plus 1. Yep, that's good. So modulus of that is 1, and then the modulus of the product is the product of the moduluses, minus 2i modulus times, actually I'll realise the denominator here, multiply top and bottom by I. Let's put I squared, that I isn't very nice. Actually, you know what, I'll just put minus 1, given we all know that I squared is minus 1. There we go. Oh, it's much nicer. Equals 1. Right, what have I got? What's the modulus of minus 2i? Well, minus 2i lives here on the Argand diagram, and the distance to the origin is 2. So the modulus is 2, and I've got w plus a half I equals 1, and that gives me w plus a half I equals a half. Hooray! I now recognise it, and so do you, I hope. So what have we got? W plus a half I equals a half. It is a circle, and the centre of the circle, if we write it as w minus a half I equals a half, then you can see that the centre of the circle is at minus half an I, so that's there, and the radius of the circle is a half, so it'll look like that. And this is a half, minus a half I, down there, and that's the range there. Now that was fun. What if we do it the other way? So I want to use the fact that y is 0. So what am I going to need? I'm going to need z equals something plus I something. And then this bit here is y, so this bit here is 0. So I have to start, and then I can use that. So I have to start with z equals. So I have to do this little bit of work again. Well, not again, not if I'd actually remembered it from last time. W equals 1 over z plus I. W, z plus I is 1. W equals, nope, z equals z equals 1 over w minus I. Good. Okay, so z is 1 over w minus I. Now we're going to sub in u plus iv because we know that we need to be working in our component form. So this is 1 over u plus iv minus I. Rationalise, realise the denominator. It's quite an easy one. U squared plus v squared minus I. Let's make a common denominator. And then tidy it all up. So we've got u minus iv minus I u squared minus iv squared all over u squared plus v squared. And putting that in its real and imaginary parts, u over u squared plus v squared, that's the x, plus I minus v minus u squared minus v squared all over u squared plus v squared, and that is our y. And this is the bit, because all of these equal z, z equals z equals z equals, so z equals x plus I y, and y is 0. Y equals 0, so minus v minus u squared minus v squared equal over u squared plus v squared equals 0. Let's times both sides by u squared plus v squared and then by minus 1. We get u squared plus v equals 0. U squared plus, let's complete the square of the v's, and we get u squared plus v plus a half squared equals a quarter, and that is a circle. And thank goodness, because that's what we got last time. The centre of the circle is minus a half on the v-axis, that's minus half I. This is the radius squared, so the radius must have been a half, which is exactly what we got last time.